Hi, my name is R.M. Arish Pawan. I'm studying in Sri Venkateswara College of Engineering. Today I am going to explain you about depth first search. Introduction to depth first search. The depth first is an algorithm used to traverse or search tree or a graph its data structure. It starts root node and explores the possible along each branch before backtracking. This is used to visit all vertices of a graph in a depthward motion. DFS uses stack to remember to get next vertex to start from tree while BFS uses queue from for the same purpose. Definition and purpose of the depth first search. Definition: depth first search is an algorithm used to traverse or research a tree or a graph data structure. It starts at the root node and explores as far as possible along each branch before backtracking. Purpose: the main purpose of the DFS is to visit all the vertices of a graph in a depthward motion. It used in a various applications such as solving mazes, topological and sorting and garbage collection among the others. Basic algorithm of the depth first search: stack based approach and recursive based approach. Coming to first point, stack based approach. DFS uses a stack to remember to get the next vertex to start from a sim tree while BFS uses queue for the same purpose. Recursive approach. In the recursive implementation of a DFS, a function is called the that walks as far as possible along the branches then the backtracks. Depth search traversal order: first pre-order, second in order and third order post order. Pre-order: visit the current vertex before its child vertices. In order: visit the left child then the current vertex and finally right child. Post order: visit the current vertex after its child vertices. Depth first search applications: maze solving. DFS is commonly used to traverse a maze and find a path from the starting point to end point. Topological sorting: it is used to schedule tasks in an order to that respect task dependencies. For an example, in a construction project, certain tasks must be completed before others can start. Garbage collection: DFS is an essential process involved in garbage collection to allocate memory and reclaim resource. Advantages and disadvantages of the depth first search. Advantages: simple implementation. Disadvantages are it may not find the shortest path to destination. Space efficient, can be faster in practice or many graph. Disadvantages: it can trapped into infinite loop in the graph with cycle. It may get stuck in dead end in maze. Time and space complexity of a depth first search. Time complexity. Time complexity of a DFS is OV plus E, where V is number of vertices and E is the number of edges. Space complexity of a DFS is for the stack space used to recursive implementation. Depth first versus breadth first search. DFS traverse by moving an adjacent to unvisited vertex, and if no adjacent vertex is found, if it backtracks to the nearest vertex that is as unvisited neighbor. Traverse by visiting all vertices at a given depth before moving to the vertices at the next depth level. first search variations. Iterative depth first search. This variation of a depth first search uses stacked data structures to keep track nodes to be backed up when dead end is reached. Multiple start depth first search. Multiple nodes can be used at starting points for traversal, each spanning an independent DFS search. Conclusion and summary. Depth first search is a fundamental algorithm that traverses or searches tree or a graph data structures. It has numerous applications and variations, each it with its own advantages and disadvantages. Understanding the algorithm basics, principles, traversal order, time and space, complexity and comparison with algorithm be like breadth first search is essential for any computer science enthusiast or professional. Thank you for watching my video.